Okay, so we are in Generalized Linear Models with examples in R, Chapter 3, that book there. And we're down in question 3.21. Okay, so here's the question. So we're looking at a data set called paper, and we'll look at that data set in just a second here. It's assessing the relationship between strength of Kraft paper with how much hardwood it has as part of the constitution of the paper. So let's load the GLM's data package and look at the first few rows of the data set. Okay, so you see this is what we have here. So we have strength as a function of hardwood, or I shouldn't say it's a function of, but we have strength and hardwood listed here. And so first we're going to just plot strength against hardwood to see that there is a nonlinear relationship. Okay, and so pretty clearly a nonlinear relationship as we go across with hardwood. Seems like strength kind of maybe goes up for a while, and then too much hardwood maybe starts to make the paper too brittle or something. So when I look at this, I think it's a parabola. So maybe a second degree polynomial might make sense here, or something like that, but we'll continue to explore that. So in the next part here, it says determine a suitable polynomial model. Now using the function poly here. So it doesn't say find the best, but I'm going to look for the best one, and by best, I'm going to define it as the one with the lowest AIC score, but you might have other criteria. So we'll do that. So you can look at my code, but basically I am running a for loop through all the possible degrees of a polynomial, okay, given our data set. And so each degree polynomial will have its own model, and then I'll look at the AIC values of those models and then pick the best one, the one with the lowest value. So when we run this, this is what we get, and it looks like the best AIC value is at 11, at polynomial degree 11, which is a little bit surprising, but there you go. So now we're going to do the same thing, but this time we're going to use a regression spline. So hopefully you've read the chapter and understand how regression splines kind of work. But roughly, whereas a polynomial is fitting a polynomial function to kind of get into these little bends and curves in the data, what a spline does instead is it sets what are called knots intermittently across the x-axis, and then it fits lines between those knots, right? So I might have a knot here at 4 and another knot at 8, and then maybe another one at 12 here, right? And so it would fit a line between 4 to 8 and then 8 to 12, but it's not exactly a line because it also tries to make that line smooth at the knots, right? So that at the knot, it's not just simply making a hard turn, it makes it differentiable. So usually it makes the second degree derivative of this segment and the segment before and after equal, right? So it makes a nice smooth line. So yeah. So anyway, so we'll do that. We'll do the same process for splines. And so we're now, instead of setting the degree of polynomial, we're setting a different number of spline or knots, right, in our spline. Okay. And so here it looks like roughly 18 is the best, which again is 15, 16, 17, 18. 2, 3, 4, 5. Yeah. Okay. So there you go. And so now we're going to plot these, right? So I'm creating a sequence which is meant to represent different values of hardwood, and then I'm just predicting the values for the best polynomial model and the best spline model as I've defined them, and then we'll plot those and see what that looks like. Okay. So again, we have the raw data as dots here, and then we have the polynomial in blue. Okay, that's a little bit hard to see. I'm going to change the width here. Do that again. sorry. Let's try that. How does this one look? Yeah, I like that better. Okay, so we see the two fits here. As far as comments goes, I guess I would say that they're really about the same, or they're very similar. I don't know what else to say about it, but they're both providing a decent fit. One thing that is not shown on the graph here, though, and one of the problems with polynomials is if we were to extend out beyond these, the ranges that are visible in the data, the polynomial might look very peculiar. It might do all sorts of wild things, and typically splines are a little bit resistant to that. But at least interpolating within the data, they're really fitting the data pretty similarly. Okay, I guess we'll call that good.